Yeah, I mean, today we were actually a lot of people in the office, and during Corona it's been not completely closed, but very few people there. But today it was actually a bit of chaos because all the meetings rooms in our office was occupied. So I was trying to get a call in, but I had to do it somewhere else. And one guy, he actually had to go into the bathroom to make his call.
So you miss Corona and hope for another wave, perhaps, to come around soon. So you have more free.
But this is a happy sort of
happy annoyance.
Yeah, exactly.
That's cool.
Yeah, that's certainly annoying. So you are working partly from home still, or are you all coming to the office these days, or what's the current status?
Well, I'm just talking for myself. I have kids, so and I recently got my second kid. So Corona.
Oh, congratulations!
Thank you. Corona has been pretty good to me.
Yeah, productive.
Yeah, working from home, it's great. So I'll probably continue with that. But I think for a lot of people at Moduli, I think that working from the office is more attractive.
Yeah. And why is that?
Well, I mean, being able to socialize, talk about things, have a whiteboard session and so on, learn from each other.
But I really think knowledge intensive type work, you thrive off each other. Your learning curve becomes faster. How can you really get that energy around excitement around stuff if you don't meet and talk about it? We try to do it, but I think that's an edge, especially in your type of company, I think.
Definitely.
But do you have a plan ahead? What will you do post Corona? Will you have some kind of part-time office, part-time working from home, or do you have any kind of idea of what will be the modus operandi in half a year?
I mean, we are solving problems, and we don't really define. Like, you have to be in the office, and you should not be in the office. Of course, we follow the Corona restrictions, but then it's up to the people. I mean, how can you work together as a team to solve a problem? So right now we have people working from India. Before they were working from Italy or Norway or wherever. And we have also, we are working on projects in New Zealand or Finland or wherever. Then it doesn't really make sense. Huh? But of course there will be more and more office, and especially our whiteboard. It's not very digital, but it's something that we use very much and like.
And do you have your favorite digital whiteboard out in the? Now we're marketing. I don't care.
No, actually,
have you found one that really works for your team?
We haven't been using digital whiteboards very much. So usually one person has been in the office or somewhere else and drawing on the whiteboard. So we have not really been using digital whiteboards. Huh?
Because that has been one thing, to try to figure out this co-creation mode. How do you do that digitally? I think that has been quite tricky. We've been using Miro. We think that is quite good. But that has been the co-creation part is really hard without a whiteboard.
I agree. And I think Miro has grown on me a lot.
Yes.
Also,
that's the only one I can stand.
Yeah, really.
I think it's good, but it's a learning curve.
Awesome. Well, it's an honor to have you all three here. It's the first time we have a triple of guests, so to speak.
And now this is a proper after work, Anders.
Yeah, it is.
Now actually I can talk to my wife. Did you have an after work? Yes, we did. We were 5.
So very welcome here, Erik Dahlberg and Magnus Isenberg and Emil Larsson. All part of I think one of the best ML consultancies in Sweden, if I may say so, called, I'm not sure if I'm going to pronounce it correctly, Module AI.
No, Moduli.
Moduli.
You did it on purpose, Anders.
Can perhaps, before we go into the introduction, can you just give us a brief history about the name of Moduli, or whatever you would like to pronounce it?
Okay, so Erik, one of the co-founders, me and Joseph and Puya, when we founded the company, we had a session, basically, a real whiteboard session.
Yeah.
And we put a lot of post-it notes on a whiteboard and had various very strange names for the company.
Yeah.
But we ended up with something with module, like we were trying to modularize something.
So it is a module, proper name
but
thing.
Also moduli always also has mathematical connotations.
What was that?
Moduli. The moduli in I don't remember actually, but it's something about the.
This is not
moduli,
very good.
the moduli in of a vector, for example. That's the length of it, right? I think.
I haven't heard about that.
There's something there. I don't
Google,
remember.
we Google it. Moduli
I should really talk to Joseph about this.
Yeah, that's part of your DNA story.
Yeah. Let's go into the history of moduli. Is that correct? Moduli?
Moduli.
Moduli.
I say moduli. Some other people say moduli. It's okay.
Yeah. But perhaps let's start with the personal background. And Erik, if you were to start, can you give a brief introduction to who Erik is?
Sure. Well, studied at KTH. I did some physics there and did some business studies, but I was kind of torn between those two worlds. I really wanted to go into particle physics, so I spent some time at CERN searching for the Higgs boson, if you know.
Yeah, of course. The God's particle, right?
The God particle.
The God particle.
And I was so fortunate because when I did my master thesis, they discovered it. So I was at CERN at the time.
You said we were?
No, I was down here in the hierarchy. So I was not contributing at all. But I applied some machine learning methods to try to find it in data from the Large Hadron Collider.
And I think physics is a hobby interest of mine as well. But still, if you were to try in let's say in a natural language describe what the Higgs boson is, how would you describe it?
It's one of the fundamental particles in the standard model, which is the model which is adopted by the physics community at this point in time. So,
and one of the biggest discoveries, right, in recent.
Absolutely, it was the remaining piece of the puzzle. All of the other particles were already discovered, experimentally verified, and this particle was not experimentally verified, so it was the last verification of the standard model.
So you had a theory that basically predicted that this particle should exist, but they couldn't experimentally show it until very recently, right?
Yes, and it was a very big reason for why they built the Large Hadron Collider, was to be able to collect enough data to be able to show that it actually exists.
And the LHC, I guess, is like a multi-billion-dollar project, right? With many countries working together to try to solve that, right?
Yeah, it's amazing.
The pictures you see, like some of these aerial photos of the CERN facility, is quite impressive. It's like something out of a Bond movie or something. I don't know. It's huge.
Quite an amazing place to visit. I think that it was. I can tell you something interesting about it if you want to before we get into the machine learning. Well, so it's like. It's obviously like a walled off. There's a lot of security around it, but it's a pretty large area. If you haven't been there, have you been there? By the way,
no.
No,
it's
no,
it's CERN. So, and the Large Hadron Collider is underground. But there are a lot of buildings. So when I was down there, I asked someone, my supervisor at the time, and asked, why are there so many buildings? I mean. Some of them seem completely deserted. And he told me, I don't know if this is true because I haven't verified it, but that the reason why a lot of those buildings are abandoned basically is because they belong to like old projects and that they aren't being maintained because the countries that contribute to CERN want to contribute to the new cool like physics. So they build a new building if they want to do something new, and the maintenance of the old ones is just completely forgotten. So you have like all this history of old buildings there with old physics projects, things standing around.
It sounds like the strip of Las Vegas. You need to be the coolest casino in town, so you need to rebuild it and tear it down. If you want to be part of the cutting edge.
Yeah, exactly. So you build a new building, do some cool experiments. But now everybody was focused on that Large Hadron Collider and those experiments there. But that's the core of my kind of that was my big interest, and then I got into machine learning because was
that during your masters, or was the machine learning interest did it come later, or how did you get interested in machine learning?
Well, I was actually kind of I knew a guy that was very that was working as a recruiter for Klarna in 2010, and so I started working there as an intern and starting to apply like very basic, modeling methods to the credit problem, which was credit risk problem.
So risk analysis or credit scoring, or
credit scoring, basically.
Credit underwriting, credit scoring.
Yeah, exactly. And that was the first time that they applied statistical methods to
and this is back in 2010, 11?
Yeah.
11.
And then that grew, obviously, because that became a big part of Klarna's
core.
Yeah, so I stayed there until at the end of 2017.
Let's wait with the moduli introduction. But cool. So you stayed a lot, and it seems like a large number of you come from Klarna for some reason. That would be interesting to hear why, but I have some other stories that is... No, let's skip that. Cool. Thank you, Erik. And let's move to Magnus Isenberg. And how would you describe your background? Who is Magnus?
Yeah, so basically I'm a very simple person. I like to solve problems. And at university I was studying both business and data. Mm-hmm. They were calling it datavetare or informatics or something at that time. And I started in 2004 to try to understand. I was working with one of the large retailers here in the Nordics, trying to figure out what people were saying and what they were actually doing. Mm. And at that time we were applying a lot of machine learning, not just to this problem, but normal like churn models, upsell, cross-sell, and this kind of stuff, and large-scale A/B testing. So in 2004, I thought that was normal to do everywhere. Mm. And then I thought, wow, this is really, really fun to work with. But I'm not competent myself to put anything into production. So since 2004, I've been working with machine learning and advanced analytics. And my specialty is to define the problems and how the solutions will be used, and also to support the teams. So basically, I'm the only one that is not with a physics or math background at Model I. And I'm supporting the rest of the people now.
You're the one with the coolest title, I think. Right? In Model I.
It's Director of Dream Realization. I think the idea...
that is a good one. That is a good one.
It's not just about dreams, but it's just like people are talking about why do you succeed or not with machine learning, and there's a lot of excuses. I think that the most important factor is always, what do you want to do? And are you really convinced that you want to do this? Yeah. And then you can do it. And so that's basically what I'm trying to help our own team or clients to find out. What do we really want to do, and do we really want to do it?
Right. But this is one of those park it and put it on the list, because we can talk about what is the real problem. Is machine learning a tech problem?
Right.
Is it really a tech problem today with the expertise we have around us? Why normal enterprises is not getting ahead of in AI? No. It's something else, right? It's the people. It's translating from business to analytics problem to data problem, and then visualizing from what let's not go there now, but let's park that one. I fully agree with you. What's the title again? How do you shorten that? Head of Dream HDR.
DDR.
Director of Dream DDR.
I'm not using it all the time, but it's on LinkedIn at least.
Yeah, but it's cool. We really like it.
Awesome. And Emil, welcome here.
Thank you.
Who is Emil?
So like Erik, Josef, and Puya, my background is in also physics. So I studied engineering physics in Uppsala. And I don't know exactly when I started getting into that, but I got into more of the computational side. So computational physics and those type of courses.
So you're into machine learning already back in your
university studies?
Days?
Yeah, so it began when I did I did an exchange year in Vancouver. I went to University of British Columbia, and I took a course there in machine learning with this amazing lecturer, Nando de Freitas or something. Yeah, he's so I think he's actually at DeepMind now. I'm not sure.
Really?
So that course was really good, and I think I already then knew that this is probably what I want to go into and focus. So when coming back from that year, I started looking for master thesis placements, and ended up at Klarna with Erik and Josef as my supervisors. So that's how we started our sort of journey together.
So your master thesis was connected to a problem at Klarna.
Yeah.
What was it?
Very vaguely, I would say. I mean, it was kind of interesting. So this was in 2012. We started discussing this. So before this whole deep learning era. So the idea was to use restricted Boltzmann machines. So this is an interesting topic, but to sort of use that on credit scoring and see if we can not actually doing the credit scoring by itself using those, but to find interesting features that you can introduce into the existing models. So that was an interesting topic, very sort of a bit out there. I think Josef had read some interesting papers.
So I have this crazy idea. What if we do this for this problem?
Exactly, and that's why you bring in master thesis students, right?
Cheap for free.
Those. Yeah.
Oh, you never know, right?
Yeah, exactly. No, I mean it was not put into production, but I think it gave some interesting.
And Joseph is one of the founders as well, right?
Right. Yeah. And so then I started working at Klarna as well. So we all worked there at the same time. So that's how we sort of got to know each other more. And when I heard that they were starting this company, I quickly jumped on that. Yeah, exactly.
What did you work with mainly at Klarna? Right?
Yeah, so I wasn't in the team of credit risk and credit scoring. So I worked closely to that, but it was more sort of on the product, more towards the sort of front end of things. So how can you use machine learning to customize the checkout experience? So they launched this Klarna checkout that was basically a really smooth way to improve conversion basically on checkouts for different.
So basically the problem is that people are almost checking out, but in the end they don't make the purchase. So how can we make that smoother and have a higher conversion?
Exactly. So the idea was basically we know usually your previous purchases and so on, and then we can customize the checkout.
Pre-populate and all that.
Pre-populate and customize the checkout experience for different people and different sort of use cases. Maybe if you buy a really expensive sofa, then maybe you want to use one type of payment option. But if you buy something else, you want to use something else.
Awesome. And let's get into Moduli. I had a really hard time saying that.
I think it's the super simplest and best name ever. So I don't know.
But before that, I mean, since you both at least have experience from Klarna, it would be fun to just hear perhaps some pros and cons of Klarna as a company, if you'd like to mention a few pros and cons.
Okay, I can start. Pros, very, very driven organization.
Yeah.
Super focused.
Yeah.
And in my opinion, I mean, different people have different opinions about Sebastian Szymatkowski, the CEO, but in my opinion, he's a very inspiring leader. It sounds a bit weird, but a very, very inspiring leader, and Klarna is almost like a cult in the kind of positive sense of the word, in my opinion.
What do you mean, like the community, the feeling, the Klarna?
Yeah.
The Klarna
like we're
eats.
doing this together. We're going to take over the world, like aim for the stars kind of mentality.
I mean, it is one of the Swedish superstars for sure.
We really are in wonder of the superstar Klarna on a global scale.
Yeah, and you are when you were working there too. I mean, and it's a nice feeling to kind of work. On the negative side, I would say that things were done. I worked there until the end of 2017, so I don't know how relevant that is anymore. But it was a shooting from the hip culture, like finish things really, really fast, and like a lot of pressure with deadlines and so on, like trying to squeeze as much out of people as possible in the shortest amount of time. Which is kind of connected to the first.
But that's the downside. If you have a driven company, it kinds to push the pressure up a little bit. So it's a little bit like, well, it's the other side of the same coin.
It is the other side.
You could try to do it in an utopian way, but tricky.
Yeah. But I mean, I remember conversations where you said that something would take maybe 3 weeks to finish, and somebody said, well, you have 1 week.
Classic.
Sounds like Elon Musk almost.
Classic.
Things like that.
Is that Swedish, or that to me is something, I mean, like if you look at different cultures or different, maybe that has nothing to do with, but it's un-Swedish almost.
Well, so we had various CROs, like leaders of the risk organizations, and they came from Israel, the United States, South Africa, and Sweden. So it was a bit different leadership style.
But it means Klarna already, even if it's a Swedish founded company, when it goes so big, it starts to become a global player, and then you have global talent, and then you have a global culture, and so the drivenness comes from many different cultures where that kind of attitude is quite common, I guess.
Absolutely.
Yeah.
Awesome. Would you agree, Emil? Or
yeah, I mean,
anything to add?
Yeah, and I don't know, maybe from what I've heard, that it was even more sort of driven like that before I joined, and like you were there a lot, but earlier. So I don't know. Would you say that it trended to be more relaxed over time, or was it?
It became more structured and thus more relaxed and more productive. But in the beginning, one of my colleagues, he was working maybe 8 or 10 weeks in a row when he started without any weekends.
Oh, really?
That was the start. And I was working like between 9 in the morning and 12 o'clock at night, almost daily for a long time. So we had a lot of, but it was a fun time. Like
fun time, but high pressure.
Yeah,
pressure cooker.
The dog years.
Cool.
Cool. Well, should we move into Moduli?
But actually, before we go into Moduli, what's the personal connection between the three of you, or how did do you remember when you first met each other? Can you place that, if that was in Klarna, or where was it? When did you guys first lay eyes on each other, so to speak?
Yeah, so me and Erik, we met each other 2012. Yeah, when I was interviewing for my master thesis.
Yeah, you had Erik as one of your supervisors.
Yeah, exactly. And I remember that meeting very clearly, because I think, because I did it with a friend of mine, and we were in this meeting. We were like so obviously super nervous. We always with the jacket on, the suit jacket on, because we were meeting a serious company. You have to represent it. And I remember going away from that meeting and being like, "Oh, we bombed that one. That was terrible." I don't remember exactly what the problem was, but
so you were a student, at this cool company. I want to do my master's thesis here.
Yeah, and we were asked to. I think it was like, can you describe base theory or something like that? I don't know. Right. Yeah, and it was terrible.
You gave him a bad, let's try him out. I love it.
So we were almost already calling in the next company on the list. So that's how we met each other. And apparently I didn't do too bad. So now he's actually hired me like twice.
Yeah.
Nice.
Same mistake twice.
Yeah.
Not a mistake.
No.
Awesome. But okay, so you were working at Klarna, Erik, and at some point you got thinking of Moduli. How did that happen, or what was your thinking?
Well, so we had been. I really wanted to kind of create something inspired by some friends of mine that started companies, but also by Klarna, and I had some discussions. You know, when you like talk to people, random people about like business ideas for ages, and nothing really happens. Nothing really happens. We had those kind of moments, but then when I and Puya started talking, things really started to happen, and we weren't sure if we were going to create a product or do something else. And then Joseph jumped on the train, and then we really figure out that our common passion is machine learning. We really want to, create an environment where we
Didn't
can learn.
Klarna do much machine learning, or
sorry,
didn't Klarna do a lot of machine learning at that time, or was it hard to?
Well, I was stuck in I had some R&D projects, but I was like the lead for credit, and
right.
It was a lot of admin and a team, like managing the teams and one-on-ones, and
it was more big company. It was already, Klarna is already becoming an enterprise in that sense, that you need to take on roles that is not only passionate about
absolutely
your machine learning. You need to be a boss as well.
Yeah, I tried to stay away from becoming a manager for a long time, and my official title was never manager, but I had a lot of administrative responsibilities in the end, and I really want to get back into coding and continuing with machine learning, and that was the common denominator for all of us.
So what, do you remember the sort of the first workshops? You said something how you were brainstorming your name and stuff like that. Do you remember that part? How did that go about?
Well, we just met in Puya's apartment and talked about what to call the company. Like, we put some post-its on the wall, and
who is it? Puya, yourself, Josef.
Exactly. Yeah. And then we were actually fully covered, or what do you say? Like, we had full coverage with projects from day one. Okay. We said, well, let's start the 1st of April 2018.
How did you find the initial customers?
They found us some strange ways.
Really? So you started a company first, and then.
But how the fuck do they found you when you haven't even started? That's a good one. I want to learn that one.
Yeah, one tried to recruit me, and then I just swayed around and say, well, can we do it as a project instead? And another one. That was actually 2 projects that came that way. And then we had an ongoing project that was Puya's, because he had freelanced some before, and Joseph quickly found a project with one of his contacts too.
So then you start cash flow positive. So you start this company, and you have a small clientele of, in different ways. Okay, we have a portfolio here to start working on, to do consulting, I guess, solving their problems.
Yeah.
Perfect.
Exactly.
Do you remember the first machine learning problem you had in Moduli?
It was a recommender system.
Mm-hmm.
Yeah.
Interesting. That's another good topic of discussion, I think.
To discuss.
But still, how did it start? I mean, did you do it on the side to begin with, or was it you just quit in Klarna and just hope for the best and went for it? Or
yeah, basically.
Really?
Yeah.
Oh.
Cool.
I mean, Puya had the smoothest transition because he was already freelancing. Joseph quit, and I quit, and then I had a couple of months off. Spent a month in Portugal, and then we started a company.
Oh, nice.
And this is 2008, right?
18.
18.
Yeah, 18.
8. Yes, yeah, I thought you said 8 before. No. Because that would have been a very early machine learning company in 8. I was super impressed there for 2 minutes.
Well, that would have been really impressive. And hard, I guess.
Very hard.
Yeah,
for sure. Okay, so you got started. You three, I guess, in the beginning. Were you all three there from the start, or?
Well, yeah, we started from the April, but Emil came in very, very early. I mean, he contacted us like a few months in.
You sniffed it out and say, "Hey, man, I want to be part of this."
And then we just said yes, of course. And we had some sparkling wine.
Right. But I remember actually at some point you were like, "Whoa, this was a bit earlier recruiting than we anticipated." Like you weren't actually looking for people at that point, but then I managed to convince you, or I think we convinced each other.
We did.
Yeah, the sparkling wine probably helped.
Yeah.
Taking away the risk aversion.
But thinking, if other people are listening right now and they have the same thought, they may not be super happy with the current employment and they want to start some, new company on their own. Is there any specific advice you would like to give them? I mean, it sounds like you had a very smooth ride, and I think it's
impressively smooth.
It's very few that can do that, but still, for anyone that is listening and say, I want to do that as well. What kind of learnings could you offer them in getting started with their own company?
Please.
It's Magnus here. I think the best advice is just to quit your old job. That's what I did. I just quit my job, and then I was thinking, oh, wow, I would like to do something with machine learning. I think it's a great opportunity here. And then I was asking people about that I know from before. Yeah. What's the best people that you know in machine learning? Then I went to them and I talked to them, and then I went to the next. And I went to Georgia, met some interesting companies there. Yeah. Went to Finland, I went to other countries, but mostly in Sweden. And then I met Erik here at Centralstationen by recommendation. Then said, wow, this is the team I would like to work together with. So, but the thing is, if you don't just say like, I want to do this, it will never happen.
So your journey was a little bit, you were in one place. Which company were you in when you decided this, I need to do my own thing?
So basically I was running a company called Big Data Pump.
Oh, yes.
That was a data science machine learning company that was big maybe 7 years ago, something like that. And I was running the operations in Sweden. And then we got bought by one of the large players.
Yes, remember this?
CGI. And then I thought, wow, they have a lot of great stuff in this company, but
it's not the same.
I would like to really be hyper-focused on machine learning, and I would like to work with a small team. And then I thought I need to find something new.
And so the core advice here is a little bit like, take the plunge, and okay, so that's, how do you convince yourself that there is, that you're willing to take the risk? I mean, like, I have 3 kids. Yeah, I don't know what your situation is. So how did you work it out in your mind that it was worth to take the risk? Because I think a lot of people, myself included, who's done this, is a little bit like, you justify why you're staying in one way, and then you're justifying why you're leaving in another way. You need to make that mental shift. How was your mental shift, or how were you thinking, or on this?
Yeah, first, I mean, I'm not changing jobs very often. So when I start something, I'm very loyal. So, but then when I decided, it's like, I have a good life. I don't need all the money, and I'm looking for something that is fun, and it's a great opportunity. So, I mean, there's a lot of hindrance that you put to yourself. There's
exactly.
Like, okay, I have to.
That's what I meant.
To work here, I need to know what is happening, and so sometimes it's just very refreshing not to know and say like, okay, I have 3 months to find out. The worst that can happen is that I get consultants and some enterprise and doing some analytics thing. And,
is that the worst that can happen?
No, that's what I mean. That is not a very. If you have been in this space for a while, I mean, what's the worst thing that will happen? You will probably not die or starve. You will find something new.
But because I think this is the point, like the biggest blocker why you're not stopping or why you're not doing it is your mental barriers in different ways. And how you break them down, one way is to think about, well, I want to do this. I want to really give that a try. And I will really regret it if I grow old and I never tried. So then you're super keen on the positive side. But you still might have this sort of anxiety. Wow, there's so much risk in this. So then another option, what you said here, is at the same time as you're pumping yourself up, what is the worst that could happen? To simply ask you that question. So I try this now and it might be fantastic. What if that doesn't work? What is my plan B? What will happen then? And if you can realize that actually even plan B is not that, I will survive. All of a sudden the mental map has changed. I think that's how I'm really talking about myself now, by the way, how I reasoned around this kind of topic.
Yeah.
Gordon is just showing a list here of Swedish startup companies, and Module AI is there as well, together with a number of other companies. But it's impressive that you, in such a short period of time, has been able to make a stamp, so to speak, in the Swedish landscape of AI startups. So what do you think, you have grown, of course, and you become really successful, but why do you think that it is? Do you think it's about people? Do you think it's about the network? Is it about what's the reason? What's the success you think about, why Module AI worked?
Well, I think there's one factor that kind of rules them all, and that's the fact that we really like what we're doing.
Passion.
Yeah. I mean, passion is a bit of a buzzword, but yes, we really like what we're doing. We really like to learn about this field. It's not like we, doing something because we saw an industry demand and, let's say, selling screws or, doing something. It's really a deep passion for us. And it's not about only the results, it's the mathematics, it's the depth in machine learning that we really like. So,
but still, it's also about, you have to find the right customers. You have to find a way to also, produce results that makes the customers happy.
Yeah.
And you have to, I guess, make a selection on, what type of product you take on, etc. Right? And or has that just been organic and you just, or do you have some kind of method of, to choose to work with? Or
yeah, absolutely, we do. And we're very keen to keep our integrity in terms of what we do, both ethically in terms of what industries we're working with, and also when it comes to the technological aspects. We don't take on projects where machine learning is not a component. We don't do just data pipelining or analysis or things like that.
I'm thinking about Robert Luciani's video or music video. The biggest, the best. I don't do data cleaning.
We do that. We do data cleaning, but so we build end-to-end systems, right? And data cleaning is always a part of it, but we want there to be a fundamental machine learning component.
Yeah, makes a lot of sense. Okay, so you got a number of projects in the beginning, and it basically were through networks or people that try to recruit you, etc.
Yeah.
But then it grew somehow. Did you do any marketing, or how did you actually grow the company after that point?
So that leads me to Magnus, because that was the fourth or the fifth person that came on board.
Yeah.
And we had this meeting at the central station because we realized during the autumn of 2018 that we can't do all these projects and do the commercial things at the same time. Right. And we can't, and we were not, it's not really our, passion. And then we got connected, and I think we had this meeting and we clicked directly. And Magnus had a great experience with building a team too, which we didn't, obviously.
Building a team, yeah.
We built teams like Klarna and other companies, but not, building from a big team.
So Magnus, over to you then. What's your secret sauce, so to speak? How do you grow a company? The easy question.
Yeah. How do you grow a company? I don't think it's so much about growing the company. I think it's more about passion also. To say that, people see me now, you say, okay, this commercial guy is selling. But for me, it was just, in a way, I needed to explain to people that here's an opportunity and we need to solve it. So I was a consultant like 10 years ago, and I was always like trying to find problems and propose solutions. Sounds very like basic, but for me, I was never thinking of myself like a salesperson. So if you have a passion to look for those problems and say, wow, we can solve this, we can do this. I mean, that I think is very important for getting new interesting projects. And for me, it has all not been about like building growth or just get a volume. We are having a system that we call a dream list to say like, what kind of problems would you like to work with? What
Back
kind
to dreams again. So that's
yeah, but it's important. Like, and it can be a nerdy stuff. Like, I would like to work with reinforcement learning. I would like to. It can be this kind of things, but it can also be like we would like to work with precision medicine. We would like to help people with chronic diseases. How can we do this? I mean, this is an opportunity company. So everything starts like, what's our passion? How can we do? So I think to look for the passion instead of, there's a potential to grow with machine learning in fintech. It's driven by passion. And then also to make sure that we always work as a team and also learn each other stuff, and we experience things together. So it's not
how
much
big is
more
the team now?
We are about 15 people.
15.
And we
what's
have
the
some
balance? What's the profile of the 15?
The profile is very biased. We have one director of dream realization, and then we have machine learning engineers. So in our team, I mean, everyone is a machine learning engineer, and everyone should be able to do everything from defining the first, like meeting the first client or product owner to have a fully working system in production. Of course, this takes years to learn, but the idea is that everyone should know everything, but no one should really do the work alone. So that's the way we.
So you want the team, the vision, and this is part of your culture, I guess, is that we have a fundamental understanding from idea to production around machine learning, and we should be able to literally master the whole chain. Then we all know it's hard to be a master of everything that goes into that problem. But in the passion, the vision is that this is how we develop our people. Is that fair? Is that a fair summary?
Sure. Yeah, that's very fair.
And why? Why do you think like that? Why do you think that is important?
Why is it important? Well, it's like asking. Okay, this is going to sound very snobbish, but I
do it. We can take
this. This is like asking like an artist why he paints or she paints. like why do you create music? Why do you do anything in the end? Like, I mean, why do you? So I mean, we really like what we do. I mean, I love coding. I love putting my headphones on and like code away.
No, but the point is that you I think it's quite. I'm not sure if it's unique, but I think it's quite clear in your mission statement around your people. We should be able to take as a person to master machine learning. The mastery around that is from idea and conceptual idea to, exploration, and then from modeling to validation, and from validation to deployment. And here we are going, from data scientist stuff to, machine MLOps stuff. And that is, you see almost a trend now that the data scientist role has starting to get these subtitles, right? Are you an AI engineer? Are you an MLOps engineer? No, I'm a data scientist working with advanced analytics. So we're using machine learning, but we are not mastering the whole value chain from idea to production. And I think that mastery is quite cool if that's your idea, because it's hard, right? Then it's really hard.
That's the idea. Yeah, that's the idea.
Cool. Just to end the topic about, what the secret sauce, so to speak, about Moduli is, perhaps the question could be, what's the USP? What's the unique selling point, of Moduli? Why should a company contact you and ask for your help?
Yeah, I think it's very simple. I mean, we solve problems, and for us, a problem is solved when it's solved in reality. We don't talk about we do AI. We solve problems, and very seldom people are talking, we are interested in AI. They are interested in saying like, okay, how can we see if a person will feel ill from arterial fibrosis or from diabetes or something.
Right.
So that's the
type
way,
of problem you want.
That's the way we do it. And so this is very important for us. We have been doing research in diabetes for a long time. And for us, it would be a very high value if we can see what patient that will have critical conditions before they get it. And they say, wow, let's see if we can help you. And then we do it and we put it into production. So, I mean, it's like asking also Zlatan, like, okay, you play football. Everyone play football. But, I mean, it's the very simple things. Like, what are you doing that is so special? It's just we are playing football. We are doing machine learning. But for us, it's like we are solving the real problem.
But do you have any preferences in types of like domains or type of problems, type of data, type of industrial sectors or something that you prefer?
Yeah, of course. I mean, fintech, we are extremely strong because of the background in fintech. So we work a lot in fintech. Recently, we have been
Klarna-related kind of problems.
Klarna-related. And then we have been working a lot in personalization. I mean, personalization is everywhere, but in retail and fintech.
Like recommender systems or what?
Recommender system. And then recently we have been moving more and more into health to look for medical time series in cardiology and diabetes. And this is really products that we think is super meaningful and also quite hard very often. Yeah. So this is an area that we are expanding right now. And then we are also working in gaming, looking at video streams in Counter-Strike or Fortnite and so on. But that's just because we started with that, and then other people got interested, and we're doing more and more of that kind of stuff.
Not casino gaming, but
no. Gaming like Counter-Strike or Fortnite and this kind of stuff.
Can you just? I didn't understand that. What do you mean?
So basically, if you are playing a game, if you're in a tournament, something is happening. Yep. On the screen, maybe you see different icons flying by, you have different things happening on the screen. So basically we use computer vision. Maybe Erik will talk about this with synthetic data and so later. So basically we are analyzing video streams from games and from the data that we are collecting.
To what end? You can what problem are you solving then?
You can do different things with those. For example, you can improve how gamers, this is a serious sport for a lot of people. So you can help them to improve, to give them feedback. You get much more data and say, oh, Anders, if you would like to be better, consider doing like this and that, or consider to challenge this person and so on. We cannot reveal. So you
can watch the gamer as he plays and then give recommendations for how he or she should improve? Or?
Yeah, you can use this for different purposes, and there's a number of different startups.
But you don't want to really talk about this fully right now. This is a little bit secretive, I think.
Yeah, because there's a lot.
It's a cool idea that needs to be kept a little bit.
It's a lot of interesting things happening in this space right now.
Put that to the list of topics.
Gaming, but we didn't speak about that.
I'm joking. Okay. But there is so many topics that is so worthy of an after work, of an AI after work. So, and I'm expecting energy, shouting, we're talking in the mouth of each other. So we need to find those topics.
Yeah.
Both that we also will argue around, maybe, I don't know.
Oh yeah, we should find something that we
because now we have something that we can have 5 different views on the same topic. What would that be?
How about the data topic?
The data topic. Let's start with the building blocks of machine learning, right?
You mean a synthetic data kind of thing,
or anything?
Synthetic data, or sorry, okay. So
frame
synthetic data. Okay, I'll frame it. So, in my opinion, I think that a lot of the time in the real world, and I think that this is not too controversial, but data is much more important than the network architecture.
Yeah, that's an Andrew Ng kind of data-centric.
In my opinion.
So let's go with Andrew Ng's comment, and it's so funny. Everybody's been talking about data and data governance for years. Data-centric, but it's a little bit like Andrew Ng is the god. So when he makes a tweet on this, oh yeah, it's so true. And I have so many comments from in my network, which is actually more data. I've been saying this for years, and now the God said it, and now everybody listens. So let's go on that.
Well, yeah. So do you want me to make my case?
Yes.
Okay. So my case is basically let's take the case of credit decisioning, just because that's on my background. You always have an inherent bias in those data sets, right? I mean, you have something called reject bias because you reject a part of the population. So you always see like a skewed version of the truth in the end. And obviously, if you just apply just a neural network architecture on that data straight up, you're going to end up with a model that can do very weird things. And that's, in my opinion, some people tend to think that you can do like automatic machine learning on that and end up with good results. I've seen a totally different side of it where you basically end up accepting people that have really, really bad credit history because they weren't accepted before. And the ones that were accepted, they were really great in from other points of view. And that kind of creates a very big bias. And I see that bias in a lot of data that we see, and not as strong, but being able to generate data that is representative of your application, or gather data that is representative of your application is super important. More important than if you choose.
So the case is here, like, how do we invest and how do we spend our time in order to get to a better result? How much do we tune the algorithm? And how much do we really work on as representative data sets as possible? Bottom line.
Yeah, you should. I mean, it's hard to say like generally what people should do.
No, but the case is a little bit like, please don't forget the other side of the coin, so to speak.
Yes, exactly. A lot of value can be derived from structuring, normalizing and cleaning your data and making sure that it's representative.
So the boring stuff has a lot of value.
Absolutely.
But you said something else, which I think is even more interesting, that cleaning data and normalizing the data and trying to do proper data pre-processing is, of course, important. I think we can all agree on that. But then if you actually use synthetic data, that's another question.
Yes.
So can you please elaborate a bit more? What are you meaning when you say you should use synthetic data?
Sorry, what is synthetic data?
It's data that's generated by some process, that you create, right? So if you want to, for example, create a computer vision system that recognizes cars, you can pick out like a lot of in images. Let's say you can. One way of doing that would be to generate synthetic data. Would be to just take a lot of different backgrounds, images, and then put cars in them.
But that's like also data augmentation in some way.
That is a bit.
But isn't synthetic data that you're creating more and more data? Like you have a sample of which is very small, that is real data, and out of that you can sort of extrapolate synthetically, so you have a lot more data in order to make machine learning happen and stuff. Like that.
Yeah, you can do that. Yeah, right.
But that's not what you mean, or is it? Is it data augmentation that you mean, or is it truly synthetic data, generating data from scratch in some way?
Okay, well, I might use the wrong terminology here. I'm sorry about that. Maybe I'm using data augmentation here.
Okay.
But I think Emil has a very good point on this.
No, but I'm not sure if I use the right terms either. But
I don't know. Let's just talk.
No, but I think it's a super interesting area, and like when I think about data, synthetic data, I don't know if you caught Tesla's AI
Dojo.
Day.
Yes.
Oh, with the Dojo and the.
So where they build up this basically a video game of the world with cars and people walking around, like this full blown world where they can basically have the car drive around and the key thing with this data set.
And just to give some background for people that don't listen in, so the Tesla Day was like a month ago, or
something.
So they presented a number of pieces of work that they have done recently, and just spoke a bit more about how they are starting to build up the self-driving autopilot part of the car, right?
Right. And of course, they are the main source for their data set is actual, real world data sets coming from their cars. But one interesting part of it is that they're collecting this data set that's synthetic from
collecting or generating.
Generating, yeah, that's a better term.
Yes.
And what they mean is it's a key with this type of data set is that they can generate, for example, like very long-tailed examples. So
the edge use cases is really the hard problem to solve, right?
Exactly. And like for Tesla, they don't need more videos or images where the car is driving down the highway where nothing happens really. They need cases where there's a ball coming from the left and someone is braking really hard or I think in the video they had some people, a couple and a dog running down the highway. Basically, pretty hard case to find in the real world. Yeah. And the car obviously needs to know what to do in those cases. And I think that area is super interesting. And of course, it's very hard as well because you need that data to not be obviously from a completely different distribution than from
sample distribution.
Yeah, exactly. So if they actually talked about this, like if your models are very easily being able to distinguish between your generated data set and your actual data set, then you're probably in trouble.
Yeah.
So that's
because the neural network could behave weird.
Yeah, exactly. So in this case also they had this where they talk about we need to blur, have blurs from speed and like smudges from the cameras and so on. So you need to be very sort of if you're going to generate your own data, you need to be very careful, basically. And
to make it as realistic as possible.
Exactly,
right?
Yeah.
So in some cases, it's hard to basically collect data, and in those cases, it's better to generate synthetic data, right? Is that what you're saying, or?
Yeah, I mean, it's definitely not for every problem, I would say, but there's definitely.
But the real problem here, we need to get even further in autonomous driving. We need to train the machine learning algorithm on outlier cases, and there is not so many pictures on outlier cases. So how can we synthetically produce those? Something like this.
Yeah, exactly. And I think the key also is to have a good feedback loop then, and like identifying where is my model not performing well. Can I identify those cases? And if it's a very clear sort of subset of my distribution, can I enhance that and sort of make that part even stronger?
What's the potential dangers, you would say, of generating synthetic data? Do you see any potential problems with doing that?
There's definitely a ton. One key thing is that, like, if your data, as I mentioned, like if it's not similar to the actual real world data, and you're and especially if you evaluate the model that you build on top of this data, like in a simulated environment as well, then when you introduce it into the real world, it could behave very differently if it hasn't been validated. There.
Some people would even go as far as saying, if you have a model to generate the data, why should you need a model to try to interpret it?
Right. Yeah.
Right?
Yeah.
What's your answer to that?
My answer is that the generation of the data might use resources that you can't have. That are physically impossible to have at the moment of prediction, for example. So the data generation process in itself might be, using, for example, knowledge about the future, and then I think it's a good argument. But I agree with you. Like it's
there's a borderline there.
There's a borderline there, and you have to understand that if you have a model to create the data, well, that's interesting because just another take on synthetic data is that when I was at CERN, and the way that they discover particles is that they simulate the standard model, all the events that can happen have cross sections, basically probabilities. And you can generate Monte Carlo simulate that. It's super advanced Monte Carlo simulation. A lot of guys in Lund are working on that. But then you take this synthetic data that's generated from the model, and you compare it to real world events. And that's how you find particles in particle physics. So, but then, then you're verifying that your model is true, right? But that you can do with that's.
Just to give an example, I think if you do it properly, of course, it's great, and especially the data augmentation part. But just to give a perhaps counter example, just to see the dangers. If you take medical imaging, and you take like semantic segmentation of cancer tumors or something, and then you had say, the resolution that we have on these images is not good, so we can't really identify the tumor, but let's just use an AI model to try to have super resolution from these. So you just expand the resolution by using a model that potentially creates some tumor in some way. Do you see the problem with that potentially?
Yes.
What is I'm not following, but what's the problem?
Obviously, it's then generating some kind of connection. If you have a really low resolution kind of image of something, and you have a super resolution of it, then it's just inferring from something that it should be these kind of extra pixels around this tumor, and it's not real data, and then it creates something that may not exist at all in the real world. It's just it looks really good.
Looks good.
It's a circular argument.
It's a circular argument, right?
Yeah.
Okay.
So it can be super dangerous if you don't think it properly through, so to speak.
When I've been in contact and someone's been working and pitching to us around synthetic data, it has been around privacy. So how to deal with the data? You have real problems here because you need your population, but you can't really use your. You have privacy issues. So if you have a small population with consent, you can use that as and augment then a synthetic. You can sort of from this real sample expand that to a bigger sample. But what do you think about that?
One of my horrible examples. Sorry.
No, because someone pitched this to me. You might even know who they are, who pitched this, and which university they work on.
I can guess. But don't say the name.
Yeah.
But okay. Okay. Let me give an example of this, and it would be fun to hear your example of or your thoughts about this problem. So okay, we have privacy data.
Yeah.
Let's say it's not like unstructured text or anything. It's just demographics, age and text.
It's master data and attributes to master data.
Something. And you want to make a classification. Does this person have cancer or not? Or some kind of disease? Or make some kind of...
No, it's for recommender. It can be even...
Whatever.
It doesn't need to be medical.
So then you have a distribution of, this is the normal distribution for the sex. This is normal distribution for age. This is normal distribution for, the location, where income and whatnot,
whatever.
So then you have separated distributions in a non-multivariate way, and then you generate from these distributions to generate new data.
Synthetic, expanding on the same population, and that should be then correct.
And what do you think about doing something like this? Very leading question. But
I agree.
The problem obviously is that normally you have interactions between the features. If you completely remove the connection and the correlation between the features and just generate samples from a distribution completely independently from each of the features, you lose all the patterns that did exist in the real data and will have complete rubbish that you can't even train anything on. Right?
But it's interesting then because people are making serious research in this field.
I know.
And they are pushing it almost like it's ready for marketing, and interesting, right?
Okay, but let's not go too negative about synthetic data. There are
certain cases. What are the good cases?
Well, so we mentioned a couple of good cases, I think. I think that it's dangerous if you don't know what you're doing, and that's always the case when you handle data it's not only synthetic data. For example, if you don't know how your production environment is working and how data is created in the production environment, it can be a huge problem if you try to create models. I mean, if you don't know the behavior of what you're trying to model, then you might be very off, like I exemplified in the credit modeling case. So you have a lot of situations where you might end up with data sets that are not representative of your, incoming population, so to say, and that might have counterproductive results. You might even implement like a fraud detection system that lets fraudsters through, and non-fraudsters get caught. Like you might actually get.
Yeah. So be careful. Synthetic has some promise, but be very careful that you really understand your statistics and bias. And stuff like this.
I wouldn't kill off the idea.
No, not kill off the idea.
But I wouldn't go there. I would start with the data that if you have data.
But let me be a little bit more pragmatic YouTuber. Let's make a top 5 list. Most bang for the buck. Data preparation, data cleansing items for the newbies that they really, this is really, get this done. What do you think is sort of, basic stuff?
That's very domain specific.
Okay, good. But now that's rule number 1. Yeah. Data cleansing is domain specific. Boom.
Yeah. I think one no, but one thing that I think is super important, and this is really general for all type of problems, is like actually looking at a bunch of cases. Like if you have images, look at a bunch of images in your data set. If you have transaction records or something, look at a bunch of them, and get a feeling for your data set. Of course, you need to also look at your statistics and so on, but
all data cleansing is domain specific. Look at a bunch of cases in order to get a feeling for the case. Okay, 2, 3 more. You hate this shit.
You're asking very difficult questions.
But it's a good question. It's actually, if you want to give advice to people who, because I think you guys, you do some of this stuff which is high value, super high value actually, if I follow your case, and you do it out of experience. That's just what you do. It's part of your workflow, right? But if you get to someone who's quite junior, share about your workflow here.
Well, I think I agree a lot with what Emil said. The thing is, you want to look at the micro level, you want to understand even the architecture in the system where this data was generated. You want to understand if it's like customer interactions. You want to understand which customers they are.
So on a deep level, you want to understand. Go deep on how is this data.
Like draw a diagram of the architecture. Boom, and understand the APIs. That are involved, and also look at the micro level, look at the macro level, like statistical, general data set.
I think it's time to move to another topic, but it's a super interesting one, and I think potentially going to your topic, is ML a tech problem kind of question. And you have worked with a number of customers now since 2018, and if you were to just give some kind of idea about what is the main problem that is causing so many companies to fail when they try themselves to get started with AI.
Or machine learning even.
Or machine
Let's be
learning.
concrete.
Yeah, machine learning. Why are so many companies failing when they try? They all say they want to do it, but they try and usually fail. Why is that?
Okay, this sounds maybe somewhat arrogant, but the most important factor is that you decide that this is an important problem that you would like to solve. But it's the same.
Elaborate. What do you mean with that?
I fully
agree.
It's like, okay, you want to run the Stockholm Marathon. Okay. The most important factor is that you really decide you want to do this. Then you can say, oh, no, I didn't have time to train. I had the wrong clothes. Or the data quality was bad, or the team did not have the competence. There's so many excuses. So the most important thing is that this is an important problem. It's something that we have to solve, and we will do it. I mean, 60% of the companies we are working with, they are startups. For and machine learning is important for how they create value, how they operate. And they say, we just have to do this. And then people are saying, no, but in our company, we did POCs and they never go to production.
No, but what you're saying, because what you're saying now, you need to be super committed to go through the skunk work, hard yards, dog years in order to get stepwise to the point where you get to value. So is that the bottom line, commitment?
I would say dog half year, usually.
Dog half year.
But we are just working with people and companies that say, we are committed to do this. If they say, we would like to do a POC and try this out, like technical POC, I mean,
who cares?
Okay, you can read on the internet. Probably someone have been doing this before.
I like this comment.
So you really need to say that this is an important problem and we are going to solve it. And we understand even if we take Erik or Emil or whoever that is smart machine learning AI person, it's not enough. We need to work as a team and we will succeed. And I mean, the success rate is extremely high because the technology is there. And I mean, it's just that you really want to do it though.
Okay, but let's say a company comes to you and they say, I have a super important problem. I really want to solve this. And perhaps they have 3 of them. Let's say they have 3 important problems they want to solve. Do you have any way to select, which one to start with? Do you have any kind of way to evaluate, this is the best one to start with potentially?
I think very often we start with the most simple one that we can get into production and that is solving a real problem. So if I would say one single simple answer, we start with the most simple one. Because if you succeed with the most simple one, you will succeed, or you're more likely to succeed with a more complex one.
And because then you also use the simple one to learn and build the experience, build the infrastructure, build your process, so you have a better chance to tackle this more complex.
I mean, Henrik, if you're a normal person, you will say, okay, this Stockholm Marathon, but I'm also thinking of Midnattsloppet. Which one should I start with? Start with Midnattsloppet, Henrik, and then we can do it.
I love that. That was...
And then I think also with this like data quality problem, people are having a problem with data quality. And one very important point is that data quality should be as bad as possible.
This is a good. You
need to elaborate on this.
Yeah, because if you're working with machine learning, you're trying to solve a specific problem. And then if you believe that the quality comes with a cost, you should always say like, okay, how can I have a sensor that is not super good? I mean, if you look at the images, do I need a super camera that is sitting on a fighter jet, or can I use my cell phone? Yeah, a cell phone photo, that will be enough. So you try to collect data with as bad quality as possible. That
on purpose? I mean,
cost effective.
Cost effective. No, but
the rhetoric.
It's not a goal in itself to have bad quality, right? Or
but don't let that be a showstopper.
But Anders, if you go to the physical world, if I come to a large manufacturer of cars and they say, "Wow, we need 100% quality of our cars," they say, "Anders,
that's not going to
you're crazy. What do you mean? 100%? It depends how will you use this car."
But it's not a goal to have bad quality. I mean, it's just you need to have a sufficient level of quality.
You have to understand what is data quality, how do I measure it, what do I want it to be, how can I guarantee I have it on this level, and how can I make sure I use it for my machine learning purposes. And this is so immature. People saying, "Oh, we need 100% data quality. We have to improve it." Maybe you don't need to improve it. Maybe it's good enough for the thing you're going to use it.
So, but what I'm hearing is that you're picking apart all the excuses, or basically we have a lot of things that can sort of take us away from the real focus of what we should be doing. So basically, I heard this before. We should do machine learning after we have done our BI reporting, data warehouse, data catalog, and cloud journey. Then we should do machine learning. And you're basically saying, hold on, we have a machine learning problem. Let's really understand, or we have a business problem, which is this one that happens to be, you can solve it with machine learning. Yes, but you know what? Has that got anything to do with your data catalog or with your data warehouse in reality? Probably not. I think that's what you're saying. Focus on the real issue.
I think elaborate a little bit more, I don't think that data quality should be as bad as possible.
Thank you.
But I think that data quality
it's not the showstopper.
Data quality is normally not a showstopper, but you need to understand why
and what you're working on.
Exactly, but sometimes like it's a good practice to think of your. I mean, let's start start with the business problem, and then think about what do I need. I mean, I have some data. Yes, let's start with that. Build a machine learning pipeline, build a model, put that in production, and then analyze what the weakest part of the chain is, and then improve on that. And that might be data quality.
Okay, this is profound. Yeah. And I must tell a Vattenfall anecdote. Working with Vattenfall analytical platform, we were starting to go on this route. Henrik, we need to sort out data governance, data stewardship. We need to do this company-wide approach to data stewardship. How do we do it in Vattenfall? And the classical point, you get IBM in, you have your maturity level, and everybody should get on board, and we should do generic data quality when I don't even know what the data problem is that I'm trying to solve. And it's like useless. And I did one simple thing. Let's have a use case approach. Let's start with a use case. And I did one very simple thing that I'm super proud of. When we do a sort of requirement specs, like almost like, what are the key things that this system needs to handle? I simply added a category of requirements, which was called data. So basically, when you're defining what your system needs to do or your analysis needs to do, okay, we have the functional requirements for the business. They want to see this, they want to get an insight in a certain way so they can make a decision. And technically, IT understood we need to have this performance. So we need to have this type of service and storage, blah, 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 to have these response times. What is the data requirements? I added a new area. It's like, do we need to monitor this? Do you need to be able to tell your users what the data is all about, and if it's periodical reporting that all the data points has been uploaded, etc., etc., etc. So that simple fundamental point, what you said now, you need a use case first, in order to define data quality.
Yes, it's like meatloaf loppet.
That's it.
That's a use case.
Awesome.
Good.
Some people just start running. I mean, I'm all for it. I do it. But then in a business context, I think it's a good idea to have a use case.
Because then you understand because data quality is fit for purpose, right? If this is business reporting, it needs to be matching, right? If I'm doing fuzzy data, fuzzy logic, trend analysis is something else.
Yeah, I mean, some of the banks have like data quality. When they measure this, it's like, okay, so it's 1 million off. That's okay. I mean, so it's a context.
Context.
Yeah, and then you, I mean, think of it as from raw data or from creation of the data to your productionalized system. There is a lot of things that can go wrong, that can have low quality, even the model. I mean, if you
the data entry, the process, the transformation,
all of those things can be improved, obviously.
Okay, let's try to summarize this topic a bit. I'm not sure really how, but we started off a bit about what is really the problem that companies have to get started with AI or machine learning themselves.
A rabbit hole here happened.
Yes.
Sorry.
And then we try to see, that there are, of course, problems that they simply can't solve themselves. They probably don't have the competence. They don't have the know-how, basically, of how to do that. Why if a company is listening right now and they say, I so recognize myself right now. We did try this POC and we never got it to production. When is the point when they should realize that they need some help externally from a company like Moduli? Can you give, when is the point? Can you try to describe that in an easy to understand way?
I think the point is when they want to start. Because
if they want to get anything, they have to.
No, but I mean, every company that we work with is like machine learning is crucial for how we create value or operate.
Uh-huh.
This is an in-house thing.
Yeah.
We want to do this ourselves. So very often we come there and say that we will not stay here forever. We're not like a resource consultants, but we will help you to get this problem solved and to do something end to end. And then we're also helping you to get the team on board, and then we will leave you because we think this is too important for you than to leave to us over years. So we believe you will build your own team, and that's usually the way it starts. So.
Nicely put, Magnus. I think we should move to another topic, and you mentioned this now a number of times, and this is of getting the need to get the system into production in different ways, and perhaps the differences of building a POC or a proof of concept or a prototype versus doing it in production. And you have done that a number of times, of course, and have experience for that. Can you try to describe a bit what's the difference of building a proof of concept versus taking a system to production?
Engineering.
Well done. Lalle would be proud of you.
Sorry, do you want me to expand? I mean, I mean, some POCs I've seen are just Jupyter notebooks connecting to some database and doing some analysis and so on. I mean, and you end up with some results, and then someone says, "Well, why don't we just use this somehow?"
Exactly. Yeah.
I mean, but then you obviously like you need MLOps, you need
and what's MLOps?
Sorry,
what's MLOps?
Machine learning operations like DevOps in engineering is about how to productionalize machine learning.
How is it different from DevOps then, if you were to try to differentiate to the two?
You have never been doing DevOps, Erik.
What?
You've just been doing MLOps, or?
Yes. Well, it is actually, I would call it almost like an expansion of DevOps. Like you're using a lot of things directly from DevOps, a lot of practices that are common, like continuous integration, continuous deployment, and you're also using, but in machine learning operations, you might have continuous training,
right.
And you also have this data problem, that data needs to be used to create machine learning models. And in normal DevOps, I think that most of the time you're just deploying code.
But I think we can stay here a little bit now, because putting things to production is about engineering. Boom.
Yes.
And then we highlighted here, we're expanding around some jargon, but I think is absolutely critical to people to dissecate. We talk about DevOps, right? And DevOps is basically software engineering. So we learned how to build systems and how to have a continuous development and operations cycle in how we build software.
Right.
And then basically what happens when you apply software engineering practices and principles into data and algorithm-centric systems?
That's very well put. Exactly. Well, so one problem is, for example, data versioning. A huge problem that, I mean, there are ways to version your code. Git is the normal one, and but to version your data, it requires some kind of other system. So we, for example, we use data version control, and we've also used other systems to do versioning of our data, to be able to reproduce a certain, run of a machine learning pipeline, a certain machine learning experiment from end to end. Make sure that it's you can trace back the results to the input parameters and the data that was used.
This is so a lot of stuff around data versioning. This is a key.
This is a key part, and what else? I mean,
pipelines.
Obviously, data pipelines. They go
for the training data set, for everything.
Feature stores. I mean, Emil, do you want?
Yeah, you just said something there that's also super difficult. Feature store.
The feature stores are hot. What is feature stores? That's cool.
Yeah. No, I mean it's your model usually use some sort of features that are derived from the raw data, and then the question is, how do you make sure that the features that you have derived during training of your models will be exactly the same that's used when it's in production in your systems? And sometimes it's not super difficult to make sure that that's actually exactly the same. A lot of times, especially when it's low latency systems and so on, it's super difficult, and you basically never want to have duplicated code. You have some super efficient C++ Java code running in your front end that's doing some calculations, and then you have your Python code in development that they are supposed to be in sync, but they never are. So you want to avoid that, and feature stores. And there's about a bunch of this is something I would say it's been a really interesting progress in this area lately, but it's still not a solved problem, I would say. But making sure that that's actually less of a problem than, for example, when we worked at Klarna, there was a big thing that people were working on.
But we have there's a little bit like, and I'm the newbie, I'm the novice, not the newbie, the novice. Software engineering has its fundamental cycle of how we understand the problem, and then we code the problem. And when you go into machine learning type problems, the process is quite different, because you need to first explore, you need to find the right variables, you need to build the training data set, and then you need to basically test all the different versions until you get to this is the best model, and then I need to validate, and then when I think that's done, I need to deploy that, and then I need to containerize that or something to put it in production. So it's a little bit like, it's one process is to find the model, and then it's all this engineering that comes when I'm happy as a data scientist to sort of boom. I think that is very different to a pure DevOps software engineering process.
That is probably very different. Yeah, I've never worked as a pure software engineer, so I've
oh really?
No, I haven't. Yes, exactly. I mean, you do all these steps and you end up with a model. Hopefully you're doing all of this iteratively, and hopefully you're not deploying like at the very, very end of your project.
No,
because that's usually a bad idea. Like you can include the productionalization in that argument.
You can work smartly from
it. And you can also deploy it full like machine learning pipeline so that you automate the whole creation of the machine learning models.
But what you said right now, it might be quite profound. The difference when I start a project and I have a pilot mindset, I started in fundamentally the wrong way in my Jupyter notebook, and I haven't thought about this. So, and this is something now we can talk. This is an after work discussion about what I'm doing, and what I think we have this discussion before. Do we like pilots? You kind of like pilots, and me, Matthias Fras, and another couple of guys, we don't like pilots. We like to have the idea of unicorn production system, but I have an MVP approach to fail fast on the bad ideas. But I fundamentally do the right things in the idea phase, in the validation phase, in the alpha beta, so to speak.
Yes, I mean, the way that I usually work, and I think most of us, all of us, mostly work is that you're not done until you have an API up and running.
But you have the other side of the coin that sometimes you really need to super fast validate and prove that this is useful. Is it any chance sometimes that you don't you cheat, so to speak?
Well, I wouldn't say. To be honest, if you have a model and you have like an artifact, and then you want to put that in production, it's not too hard. I mean, it's not too hard to just create, like, for example,
I love Flask. Argue.
But it's not too hard to just put it in, like, put up an API like Flask API or something like that to just.
But what because you think it's huge because you put another definition on that part of the process.
Yeah, but there are a lot of other things you need to do to really.
Okay, let me just quote Google from 2015. Then they claim to build a prototype or to do a model is like 5% of the work to actually build a full productionized system, which require 95% more work to actually do that, make that happen.
So if you want everything that goes into a productionized system, yes. But then there is a lot of tooling today that you can helps.
Yeah.
But Anders, I believe to start with the end, I mean, what I felt very refreshing when I met Erik and the other guys, that they were pretty destroyed from the start. And what do I mean with that? I mean, they came from, they like the space. Okay, I like space, so I study physics. And because I study physics, I end up in finance. and at that time, that was Klarna. And at Klarna, you say like, okay, you're not here to do machine learning. You're here to solve a distinct problem. And if you don't put it into production, it's pointless. So don't talk about machine learning if you don't talk about how you can improve the product. And I mean, if you have this mindset, I think we are maybe not the best persons also to, okay, what's the difference between this and that? Because the team has mainly been using just machine learning and just put it into production. So in that way, it's very simple. But I think the challenge here is that you need to be curious about the world. What's the problem you're going to solve? You need to be this like crazy scientist. Oh, I have a PhD. I'm trying different approaches.
Don't talk down to PhD.
Yeah, no, but no. But this is a very important. We have Joseph. He's always saying, he's almost screaming. I'm a scientist. I want to solve this. So you have this like research area. Like, how can we solve this in the best way possible? That's the area number 2. First, like understand the problem, then research. What's
hypothesis
the best
framing?
Yeah, what's the best way I can do this? I want to try different networks, architectures, models, and so on. And then you have the engineering side. And then even if you are this super bright person in the number 2, maybe you need to cooperate with the other people to say, oh, how do I do this clean code? How good do I get from that? So even
that's 10x, that's a magnitude more engineering work than
this is why you always have to work as a team, because no one is really good at those 3 things. Of course, you get better and better and better for every year, but it's a big failure to say, I've been working with AI for 10 years, but I've just been in number 2. And doing research on this kind of data.
I think but let's not conflate 2 different topics here. I think you're, for one, speaking about people with different skills, and some people, let's say, call them data scientists that may not know how to put stuff in production. Versus if a company really wants to find, what should I really, find as a use case that I should start working with and failing fast. That's completely 2 different questions.
2 different topics, and then the engineering topic.
The difference then is if I have, let's say, 3 or even 10 different potential use cases as a company that I can work with, then I can choose to do a number of things. 1, I can choose to take all 10 of them and put them in production and actually do the full work on all of them and see what happens. Or I can try to first evaluate what is the predictive power that we have for the data for each use case and see, is there any chance to actually do some kind of predictive work on this type of data, or is there no predictive power at all? And to answer that question, you don't need to put that system into production, and potentially can fail much faster than you could if you were to put all 10 into production first. You see what I mean?
Yes, and that's maybe we're a bit controversial here.
Yes.
But yeah, so obviously in some cases we do analysis to see, like, is there a use case here? If there are like 3 or 4 or even 10 different ideas for ways to apply machine learning. So then we look at the data, we create models, but we tend to do it not in the kind of Jupyter notebook way, but in a more like a productionalizable way. But
I think this is important, and in the work Like that's even if you have this MVP approach and not the piloting approach, they're actually more similar than we think, because the first phase of any is a hypothesis framing, right? That's the ideation phase. And then you have some feasibility, ideation, validation phase. And of course you can call that a POC if you want to. And then at some point you can see the usefulness of the business case, you can see the usefulness of the algorithm, you can see the effort and cost in order to get the data that you need, and you start to understand the feasibility of, can I make a UX, or can I make something that a normal how will this be used, right? And you can fail, in my opinion, on all of those 3 points. So you can have a very nice model, but actually the data, we will not be able to scale this up at scale, right? We can do this in a sample, but how will I do this in a bank across the globe and collect this data? The cost to do that is not feasible, So there's many ways that you want to do a pilot, but only to do a pilot on the algorithm is not enough. You need to do a feasibility view, in my opinion, on several dimensions. Then you can discuss if it's the same as production and you go the full-blown way. I get that point.
Awesome. Any final thoughts about, what it means to take a system to production? There are these, one way to call it, if you compare traditional software engineering to AI engineering, that we actually tried to coin as a term from Peltarian times. And we actually had a conference recently in ICSE, International Conference in Software Engineering, with that specific topic. And I think you phrased it really well, Erik, saying, that there is a big difference in traditional software engineering, which is it's not only about putting code in production, it's actually about putting data together with the code in production. And we don't have the tooling for that today. We don't know how to do proper data versioning, as you said. And we don't know how to do the proper operations on top of that to identify if you have a training or serving skew or some kind of data drift or whatnot. That happens, right? But you have it for code, but not for data, right?
That is extremely true, and there's a lot of theoretical work that has been done on this, but I would say, on the practical side, it's still in its infancy.
Yeah, sure. Awesome, and perhaps we could move quickly into another topic, which is more, we've spoken a number of times about Jupyter notebooks now, different tech stacks, if we call it that, that you can use. And if you would like to share, if you don't want to share, let us know and say no. But do you have any favorite tooling for putting machine learning systems into production? What is your preferred way of, what do you like to work with? What do you do not like to work with? And I'm hoping you're saying the right thing now.
No, but just connecting to the previous topic a bit, I think it's definitely in the infancy of a lot of these tools for putting things in production, but I think it's improved drastically just in a couple of years. So I think we are sort of lagging behind the software engineering in a few of those.
They've been doing it for years.
They've been doing it for so long. So I think we're catching up and
fast.
There's a lot of interesting tools and companies doing great work here. So when it comes to tools, I think this is interesting also. We have endless debates internally about, do you prefer this or that? And we definitely don't have a company you should use TensorFlow, because it's super healthy to, in my opinion at least, to explore a bunch of different tools, and you never know who's going to be the next winning thing. So we love all of these things. we talked about Jupyter notebooks here. I love them. Maybe not for everything, but they're probably a bit overused in general, but they're a really nice tool as well.
A very diplomatic answer, but if you were to put some kind of preference on some tooling you'd like a bit more than perhaps some others.
Yeah, but so if we talk about the MLOps side, I've gotten into Kubeflow in this recent time, and it's still also very much in its infancy, and
but I think it's a bit over engineered a bit though, if you do Kubeflow pipelines and these kind of things.
Yeah, it definitely have some rough edges, and like it's maybe not the easiest to work with all the time. But I think it's definitely on the right track, in my opinion.
And if you were to describe very briefly what Kubeflow is, how would you describe it?
So Kubeflow is a tool for doing a lot of the MLOps things, like versioning data and models, and like the idea is to be able to run machine learning pipelines in Kubernetes. And there's a lot of it's a full ecosystem basically. So you can have notebooks, you can have pipelines, you can have also serving in this. So it tries to sort of connect good tools in the like ecosystem and fit them together in a nice way. So you can build these sort of end-to-end pipelines and deployments. And the goal is to try to have it very sort of modularized or component
modularized.
So you can have, you can mix and match if you want to use, I don't know, PyTorch for training your models and TensorFlow for something else. Or maybe, I don't know if you you do that, but yeah, so you're not, these different components can have different technologies basically.
So use maybe 1 minute for me who doesn't really, I'm not a coder. I've heard PyTorch, TensorFlow, Kubeflow, Kubernetes. How do they relate? What's what here?
So PyTorch and TensorFlow, they're open source projects for actually training.
So libraries with Python algorithms for different purposes.
Yeah, exactly, and they're very efficient frameworks for, and very. I would say that those are the main two ones right now that are used in the community for training models.
So we had this conversation, like you're screwed if you don't go and use the open frameworks as a machine learning data scientist. That is an opinion. Is that true? Like who starts from scratch?
From scratch is impossible, but you don't need to use open source. There are actually some nice commercial tools, I've heard.
Okay, we don't talk about that. But then we have Kubeflow versus Kubernetes. What's what here?
So Kubeflow is running on top of Kubeflow is running on top of Kubernetes. And Kubernetes is this. I'm not an expert on this, but it's a tool for managing infrastructure and running different
orchestration of containers.
Container orchestration, right?
Exactly, yes.
So we have these technologies that we almost say them now like they're part of the infra today almost. So it's interesting, right? So we hear about Kubernetes, we hear about Dockers and a couple of technologies like that. And then we hear about, TensorFlow and the PyTorch libraries. And then we hear about favorite toolings to actually do your work. Is that a fair summary? I'm trying to understand. This is a little bit Greek.
These are the common ones. But I think another question that would be interesting to hear what you think about is, most of the models we use today that are coming out, every month and new versions, for NLP or for images or audio or time series or whatnot, they are usually coming out of these kind of research labs in Google, Facebook, Amazon, Microsoft, Alibaba, Tencent, blah, blah. And the quality, what do you think about the code quality in these kind of, repositories on GitHub coming from these? Any thoughts about that?
Yeah, I would say that it's varied.
Any one of these kind of big tech giants that you think has the best code quality? I know what my preference is, but
wow, that's a good question.
That is a very good question. I'm trying to think like that's a very good question. I tend to the ones I've seen from Google. I don't think that the code quality is too bad, but I haven't looked into all of them and then compare them, so I wouldn't be able to tell you.
Emil,
I would. No.
You're all fantastic.
No, I don't know.
No, but you should say the opposite. They're all horrible. Some are slightly better than horrible.
I've looked into Kubeflow, and I can agree with you when it comes to Kubeflow.
But also, I'm thinking more like if you take the latest Roberta model in NLP or something, and they have a specific repository in GitHub for that, and you want to put that specific, code and model into production, and then you have to potentially use that code base. And they have some dependencies that may not be perfectly defined. They have, some weird, very lacking test coverage, etc. Have you found that problematic in some way, or what's your experience?
We always, if we use, pre-trained models, or if we fine-tune pre-trained models, we always have, ways to test that the results are good, and that the end KPIs that we are trying to kind of meet are, or the metrics that they kind of are measuring the business impact or something like that are good. So if they don't have complete test coverage in the repository, it's a problem, obviously, but it's not like it's a huge enough problem for us to not be able to use it.
We should be happy to have something like containerization of code. Otherwise, it could probably be really problematic to keep up with all the dependencies, I guess. So there are tooling for sure to keep up with this. Okay,
I want to take a topic now.
Yep, please.
I want to go a little bit into the business and enterprise space. So we started here like, well, what is problematic, or what is the challenge, or what you need to think about when you get started with a machine learning exercise. So my hypothesis when it comes to enterprise is a little bit like if you come from an analog background, it's almost like a journey to become more data and AI ready, like your tech stack, your ways of working, your way of looking at software, which is maybe application centric, full stack within one each business application. This is a traditional enterprise environment. It has a bit of a journey to come to the kind of ways of working and operating tech and all that I think is a journey. Have you seen that, or what are sort of the, if I put the last question, when you come in, how do you fit with IT, or what is the gap? So what do you need to work on in order to make to teach them to become sort of data AI ready, to sort of take on machine learning type stack inside their environment?
Mm-hmm. Yeah,
it's a big, it's broad, like, I don't know how to, like my framing is a little bit like, what do they need to learn, in order to embrace it?
I think 60% of the companies that we are working with, they are like digitally born, and they don't have this really like IT and the business. Of course, they have tech and product or something.
But they are not the same as the traditional IT supply, IT demand.
No, they are not the traditional organizations. But in the cases where we have been working with those organizations, we have been just checking, is this an important problem? Is this solvable? And then we have been solving it. And then we are saying, okay, there's a lot of problems. It's usually like, okay, we're not on level 3 of AI maturity. So we don't really care about that. It's like, do we have a distinct problem? Do we have data? Maybe it's, okay, it's from a data warehouse. It's just update every week or whatever. Then say, okay, this is what we have now. And if personalization is important for you, let's solve it with the data that we have. And then we can discuss how do we get pipelines. It can be real time. Should have this feature store, should have yada, yada. But then it's much better to just solve it. And then say like, okay, what do we need to check? How do we have to work differently? Instead of trying to, okay, we will change IT. We build this data lake. We have stewards. We work with data quality. We prepare for machine learning. Just like do machine learning. And then it's like, okay, when you would like to do it the second time, what should we prepare better?
So it's an iterative way to go on this journey. This is not a project. This is not a re-platforming project. This is really iterative approach to become data machine learning ready.
For us, it's just like to solve this problem. And then, of course, we leave a lot of implications. Like if you had this real-time data, yada, yada, if you had better data quality, if you have this and that, it would be better. But then it's just a strong recommendation instead of saying like, okay, I'm going to run my first marathon, and what do I have to do? And I need to prepare for 8 years. It's maybe better just to run a smaller race then. And this is what we want to do. We want to do this right away and then write on a list. What can we improve for next time? And usually, like a large enterprise, they can succeed in 6 months to put something amazing in production.
But I think this is also quite profound, that, and I fully agree with that, this sort of, we are here and now we need to be data and AI company tomorrow. It won't happen like that. You simply need to start, it's a little bit like change is like pouring milk into coffee. You simply need to start pouring in order to understand, how much milk you want in your coffee. You can't really control this change, and the starting point is like they don't know what they don't know, so they kind of need to do their first projects and iterate from here in order to understand what is useful to improve and what is useful to organize differently and what tech is useful to get in. Like a lot of things. The problem is that a lot of the enterprises has gone into the whole replatforming, buying the tech first, but not really caring about the business problem. So I really think this is quite profound. It's a different mindset on how to solve this, in my opinion.
It is important. I think what you said is really important, and I wish more companies understood that you don't need to transform the whole company to get started with machine learning. You can actually start with a small use case and quickly get started with that, and then start to
understand
more, right?
what you, and every time
is that what you mean?
Yeah, and I also would like to go back like 10 minutes in time and confront you a little bit, Anders, because you said that, okay, maybe they have 10 problems. What should they start with? Mm. But if you talk to a business manager, it's like, what's your 10 most different, large problem? They don't have 10 problems. Mm. They have one. I need to find what company to invest in. Yeah. I need to give this loans, but don't get defaults. I need to. So very often they have a very few problem that is really crucial for how they operate.
Do you think they're always right in what project to start with, though?
I think the bold ones, they say that this is important for us. Here it can bring value, and then they should start with this. Of course, if they have 2 or more, it's better, because then start with a simple and you can learn a little bit and then go for the next. But very still, if they come like that, we have 10 problems, we have been doing this ideation workshop, they probably, maybe I'm not even sure if they found the most relevant use case.
But you're more sure if they have 1 than 10?
Yes.
I would
because
be too,
they are probably more focused and say that this is what we are doing. We have one problem that is really important, and we think we can do it better.
And I also think that we should distinguish between problems and problems. Some problems are just inherent in the business, like the credit scoring problem for Klarna or fraud problem. Some problems come up because you do an ideation process and you think about things like, there is something called NLP. How can we use that? Right. Well, we do have a lot of documents, and that could be used because then we could. And
this is actually dangerous. But you're going tech first still.
You're going tech first, and sometimes that's a really, really good way to find new opportunities. To be honest, but if you look at that as a problem, it's not really a problem. It's an opportunity for you to do something new that you haven't done before. But so I think what Magnus is referring to is like a real fundamental business problem that you as a manager have to kind of deal with in some way.
But I think follow-on question is the industry part of also almost skewing, blurring the picture here, because we have all these vendors and we sell AI tech, we sell machine learning tech, and it's very common that we start with the technology. This is the typical blog post, right? We have NLP. What is the opportunities with NLP or challenges that you can solve with NLPs? And I think this is a quite big difference between the enterprise world and the real tech, the startups. If you're a tech native, you are more sharp on the business problem you want to solve, and then you go after that and figure out what problems will solve that. Whilst in the enterprise space, it's a little bit like we work with all these vendors, and we get so, you need to do AI, otherwise you're dead in 5 years. And oh my God, and it's a little bit a wrong starting point. Would you agree?
Well, if you do ideation and with both a business and tech point of view, then of course you can do it right. And that would be obviously the best way to do it. That would be the best, right? Otherwise, I would be surprised.
But I like the fundamental. You know what? Let's leave tech and just ask the real problem questions.
But I would say also that, of course, tech-driven is not always bad. And I think sometimes necessary, actually. So I think having a dual approach on this, both going bottom-up and top-down, from looking from the business point of view, what you have today, but also top-down and seeing what could you actually do that you don't do today. So don't dismiss it too much.
No, and I'm sorry if I dismissed. I don't mean to dismiss it. It's just that there is potential downside with that line of thinking, like going from tech first, and I like the distinction there.
Yeah, cool. We have a very short period of time left, and I'd like to move a bit more into more philosophical questions.
Yes.
And we have so many of them. Should we? And we really have to have a bit of self-discipline here, not to speak too long about this. But you mentioned it before, Emil, about GPT-3 or NLP. So we have to take that. Let's try to have some self-discipline and not spend like half an hour speaking about this. But let me just open up with a small question and see what you think about this. So some people think, GPT-3 is I even heard today some podcast saying GPT-3 is more intelligent than the human. And I was like jumping over my motorcycle or something. But still, I must say, of course, GPT-3 is very impressive, and it certainly is moving to more general intelligence, but it also has some very big problems when it comes to practical use. What's your view of GPT-3, and should companies that you work with be interested in that?
Yeah, I mean, I think I agree with you there. It's you're actually really impressed when you see it the first time. You're like, oh, it can do all these things, and it's just like it's the same thing. It's the same model. It's just, you give it some context and some input, and then it just spits out usually reasonable things. But and I mean, this is also something like when you mention intelligence. Okay, but what is that actually? Like the definition of this one is the maybe they say that in the article there, but I would definitely not.
You have a preferred definition of intelligence, by the way?
No, I don't.
Okay,
but I know that there are some other people in our company that that have that. But GPT-3, it's to me it's sort of like a promise of something to come. Like it's super interesting, and I also don't like when people bash it the other way around, like saying like, oh, it's just a party trick and it's just for fun, and it's not.
It is really impressive.
Yeah, it's really impressive, and it's like this is something that will be built upon and will be it's promising. That's what I say about GPT-3 and models like that.
Would you agree with saying it's really promising from a more philosophical or like AGI point of view, but horrible in terms of practical use today?
I mean, horrible. I think it's there. You can definitely find really, really good use cases for it. Like if you, like this few shot thing where you have, classification.
No way. Sorry.
No.
I mean, you could easily take whatever other model and fine tune that on your own data and get like 10x performance than GPT-3 can. So GPT-3 would be horribly worse than any kind of fine tuned model that you have. Right. You can never fine tune GPT-3. So why would you ever use it for classification?
No, I mean, you wouldn't use it if you have the opportunity to use some data set that you have that you can fine tune on. But I think there are cases where you don't have that option, and you're starting from complete scratch. And I think there are problems that it could solve in that domain. But I don't think that it's not a one model fix everything. Definitely not.
I mean, it's in my opinion too expensive.
It is. You can't use it for practical use.
No, but I would not dismiss all of it because of that. I think that.
Of course, I mean, there is a good reason for OpenAI to do this, and it's a good reason for Chinese doing a 10x the size of GPT-3.
What do you think is the reason?
I'm biting my tongue. Do you know there is a Swedish version of GPT-3 going to be potentially trained soon? Or there are actually 2 versions already in Swedish. But
is that the one with the Royal Library? No.
I don't know. Maybe not.
No.
I think.
But what do you think about, okay, we should stop this discussion. This can go on forever, I can feel. Okay, let me see if we can find a common sense agreement on, the pros and cons of GPT-3 and see if you agree with it. So for one, I think we can all agree it's an astonishing research achievement that they have done with a huge amount of data and just scaling up the model size and a super simple objective, being able to solve like any kind of task without having to fine-tune for each of the tasks. So it's a very generic model moving much closer to general intelligence. Would you agree so far?
Yeah.
Yes,
I mean,
but that's completely. I mean, that's dependent on the definition of general intelligence, though.
But it can do many tasks at least without
Yes.
having to fine tune each of them. So a single model without changing it can do many tasks.
Yeah, that's obviously a move in the direction of general intelligence.
Yeah. But it's horribly bad from a practical point of view because you can fine tune it and it's worse performance than any kind of other NLP model that you have today.
We haven't put it in production, to be honest.
What?
No, but I mean, it's 2 different things. Like one thing is putting it in production yourself. That you should definitely not do. But buying API quota might be reasonable in some cases.
And if you were, for some reason, wanting to generate a lot of fake text, that would be an awesome thing to do, right? It's like a deep fake for text. Or
I start up my own publishing company, and I have an API to GPT-3, right?
Yeah. I shouldn't be as opinionated as this, I think.
But you're funny because you're opinionated and then you bite your tongue. I don't know. I don't know how that works.
Should be a scientist, objective.
You think.
Yeah, I think, yeah. Okay. One topic that we often speak about. Oh, I see it's just a few minutes left. Okay. One topic that we speak about a lot, and I think we mentioned as well here, is the AI divide. That some few companies, the big tech giants, the Google, the Facebook, the Microsoft, the Amazons, and then the Chinese, the Tencent, Baidu, and Alibaba, etc. They are the biggest and most valuable companies in the world today, and they know how to use. They have the data. They know how to use the data. They have the research groups. They have the AI systems in place in production and make large amount of money. And then I would potentially, and this is the question basically, most other companies fail when they try to put ML systems in production. Would you say that this kind of divide, if you call that the AI divide between few selected companies that can use it a lot and make a lot of money from it and most other fails, is growing or starting to catch up? Do you think that the rest of the companies in the world are starting to catch up with the tech giants, or is it still accelerating away?
I would say that's a very interesting question. I think this is a good after work question because you have both arguments here. I mean, obviously, those companies there is a law of diminishing marginal returns, but these guys are, getting more data by the second, so. Those are 2 competing forces here,
and they are doing a brain drain, from all the universities.
They're doing the brain drain, and I don't think that the rest of the world is catching up. I think that would be too optimistic. I think that there is a huge democratic problem here, to be honest, and I think that I've been trying to come up with ideas. I mean, I like to talk about wild ideas sometimes, and some of them not too practical, maybe, but ways to kind of offset that. To kind of guerrilla warfare against the big ones.
What do you mean? How should that work?
Well, I mean, okay, this is a crazy idea, but one thing that I've been thinking about, a lot of people have GPUs, right? Yeah. So if you just came together as a big,
I see. It's a crowdsourcing thing.
But that would be a horrible data distribution problem. But I was a part of CT at home back in the day. I liked like if you could create like a community or something like that, vote on the problems you want to solve, and you have the data, and you could use like millions of GPUs. Maybe you could launch that as maybe you could open source that. But that's maybe a pipe dream. I talked to Emil about it the other day, and he was like, "How is that going to work?"
But I also said I like the idea.
Yeah, you said. Oh, sorry, you weren't the one that. There was some other person. That said that.
I mean, to get a bit serious about this, I think a lot of politicians as well are starting to realize this big problem, and especially in EU, where we don't have any single big tech company that is even close to the US or Chinese companies, and they really want to fix that somehow. And they're starting to finance a number of these. They call it still HPC, high performance computing clusters, but in reality, they're putting GPUs in it and other things. So it's starting to be AI clusters that people can get access to. And we're doing the same in Sweden partly. We have the big, Berzelius in Linköping University that is a super pod of NVIDIA, or 480 A100 GPUs. And yeah, it's cool stuff. Is that the right way to go? Do politicians need to go in here and use our tax money to start to build up the infrastructure to truly make companies catch up? Or is that a good way to do it?
That's almost like a political question.
It is a political question.
But in my opinion, I think that it's good. Yes, I think they should do it because of the way that, it's a pragmatic way of thinking about things. Like, this is a problem, how can we help? That's a way of helping the situation. Should it be like that? Idealistically, maybe no. Maybe we should have done things here in the EU too, but maybe this is a result of the fact that the EU is a fragmented market, and EU and the US is not, and China is definitely not. So maybe helping out from the political side is a good idea.
Yeah.
I think all the tech giants that you are mentioning, they are solving some distinct problems and creating a distinct value. If we cannot do that, independent of what kind of value it is, I think we have very hard to catch up.
So we need to be better at defining the problem and solving the problem.
Yeah, bringing a lot of GPUs, why? And if we don't have a why do we do it? It can be simple, like we want to do advertisement in this segment or whatever, but we need to have at least a why. Like, why are we doing it? Otherwise, we will never catch up.
So this is quite interesting because they are then growing and they are extremely good, but they have also never lost sight of the business problem they are solving for their own purposes and for their own benefits, of course. That's the point that you're trying to make. If we don't have a clear problem that we are going to utilize all the tech for, it becomes a tech problem. It's tech-led discussion rather than the business-led discussion.
Yeah, I think that's the main problem. If we say, we need to catch up with those guys, and we're creating high, whatever you said with competition and so on. Why? Yeah, because we want to compete. Okay.
On what?
And it's not enough. It will just be like, okay, our IT department need to buy more GPUs and we have to get into AI. You will never succeed. Huh?
It's the same. So on a macro level, the fundamentals are the same as on micro level. So if I want to succeed with machine learning on the micro level in one company, have a burning problem first. That's kind of Model I's motto. And if I take that now, you're saying, well, doesn't that apply on a macro level as well?
Yeah, but I think the challenge is, if you're a small startup or if you're a Nordic retailer, you're not strive to have world domination. That's not why you're doing it. You want it to be more efficient in your market, or you want.
So you're not afraid about Amazon coming to Sweden?
But what I'm saying is that a lot of the players, of course, they compete with Amazon in the local market, but they're not competing on Amazon in the global market. No. And that's a big difference. So then it's very hard to challenge them when you come to resources for creating artificial intelligence or or compute and so on.
Can I jump in here because I don't fully agree with this?
Okay, awesome.
Good one, awesome.
I think that when you concentrate wealth in these companies to that degree that it's concentrated right now, they have huge purchasing power for like European companies like DeepMind, for example, that are very promising. But I think we could go and ask for like the founders to have the integrity not to sell to these tech giants and pursue their own path. But I think in the end, when the world works like it works right now, it is a problem.
But and you said something like this is ultimately a democratic problem. Could you use
it is a democratic problem because these guys are gathering huge amounts of data and are able to train machine learning systems that are way more performant than
anything else.
And that creates a huge barrier for startups or anyone to kind of compete with them, solving the business problem they're trying to solve, like search, for example. So there is no way. It's just getting harder by the minute to compete with Google, for example, and that's a problem in my opinion.
But so bottom line, we think, and I think you said it, that we are doing political investment in this, and we're not relying on the market forces alone. It's simply because we see this as a democratic problem. That is good, and we all agree with that. That I think we do at least. And you said that was your take, but then comes the next question. Okay, give me 10 billion euro or 100 billion euro. What should we do with that money? Okay, so the government is keen. We are all keen. We see the democratic problem, and we need to create some sort of position and force around this in Europe. And then the core question is, how do we spend that money? Is it on GPUs or something else? Is it to foster a lean startup startup community, or what do we do in order to combat that? Is to
super simple question. So
just get on
just
to
guide
it.
the EU politicians here now. What should we do?
Emil can answer it.
I have no idea.
Goran, the producer, has been quiet. He doesn't have a mic. He gave away his mic. I love it.
I have 10 billion euros. What should you do with that? Well,
but isn't it,
to solve the democratic problem.
It's a great question, isn't it?
It's a very big question.
It's a big question. It's a big question.
And it's a very good question. But I don't know, to be honest. It's a...
What do you think?
What do you think?
Oof. This is an after work question.
No, but one thing about shouldn't really go here, but one
he does it all the time. Come on,
yeah, but I'm thinking this can lead to another rabbit hole, and not want to. But just to say one thing that EU is doing and spending huge amount of money on is regulation, and they are putting it on a pedestal, saying we should be the guiding star when it comes to regulating AI.
AI for good, etc.
And you can think about, is that the right way to go? And they claim GDPR, for example, was a good success story for how how well it worked. I'm not so sure. And right now, we have a new AI Act and that type of regulation that is proposed, and it's a lot of negotiations right now about how that should be formulated. I'm not sure. Have you seen this new regulation coming up? Or
you're a part of that.
I've been part of it.
Yeah. I don't know. I haven't seen the. I know like GDPR and PSD2, and I love PSD2. GDPR, I think was good, but to some degree.
I heard another topic coming up here.
Okay. So, some of it.
I think the intention is no question that the intention of GDPR is great.
Yeah.
The question is the implementation, I would say. Yes, Magnus.
DIGG.
Yes.
What's the name of the myndighet? Is it Digitaliseringsmyndigheten in Sweden or something? Yeah. They came up with a report, was it last year, that AI, just the technology that we have today, could create a value of 140 billion SEK every year. It's maybe not a lot of money, I don't know. but it's quite a lot of money.
Part of GDPR or GDP.
And if you look at what you call felaktiga utbetalningar, like wrong payments from the wealth system, is about 15 billion a year. And I believe if the government was a private company like Klarna or someone, and someone said, like, okay, we are paying 15 billion SEK, or we have a potential value of 140 billion a year, I think they would say like, maybe we should try to structure some of those problems and go to solve them. Of course, I know there's a lot of people doing that, but I mean, I think that could be a good starting point, because there's obviously a value in the public sector. So there, I think it's a lot of potential.
But I think we don't have time. This is the rabbit hole. You asked me the question, what should we do about this instead? And I think we need to invest money, but I think it's in many ways you need to invest differently than use tech. You need to invest in how do we get the talent into Europe? Fundamentally, number one, we have a brain drain problem. How do we combat that? How do we make talent come into Sweden much more easily? You know, we are missing 70,000 IT workers, they say. Number one is one angle. The second angle, I think we have fundamentally a data literacy problem. So if we don't understand to ask the right question, or the potential, or the, you know, if we don't connect the $15 billion SEK problem that can be solved with tech, I mean, like, obviously we haven't done that connection yet, because then in a normal tech company, you would have been on that as a, you know, you would have been on it for immediately. So there are so many different facets of this problem that, you know, it's a little bit like, there's not, you know, putting everything in GPUs won't help, but to put it in, you know, a structured way of around talent, around fostering, you know, a startup scene, being better at defining the business problems that can be defined by tech and getting a business case behind it and start solving problems. That's how you get the momentum going. I mean, like,
or we simply need to scale up Moduli.
Oh, in Moduli,
have them help the whole.
Let's Moduli the world.
Yes,
that's my answer.
Could be good. Perhaps a final question, and this even more philosophical one, and this is going then to the singularity. Are you afraid about it? Are you concerned that at one point in time, and the question is, at what point in time will there be artificial general intelligence that are surpassing human level intelligence? Should we start with Emil?
Sure. So, yeah, I'm a bit afraid of it. I mean, I don't see any reason why it wouldn't happen at all. Like, I mean, when it's gonna come, that's the biggest question, and like no one can answer it.
So singularity will come. It's more the reason to think it will not come is slimmer than to think it's gonna come. It's more about when.
And perhaps we should just define a bit singularity versus artificial general intelligence and human level intelligence, because it's all three different things, I would say.
Yes.
So, you know, singularity is at some point where AGI will go rogue in some way, that we can't pull the plug, we lose control of it. Think Terminator, but not, or think, you know, but simply there will be a point where we will stop having control of the AI. Another point can be when we have human level intelligence, meaning that we have some system that can be as general as humans can be, which we of course don't have today and is very far from. But the third could be AGI in general. We can be extremely much more intelligent than humans, because humans are really stupid, to be frank. I mean, we can't even, you know, calculate big integers together or multiply them. I mean, we are so stupid, really, to think about it, and really narrow, actually, in the human mind. So there is another thing called AGI that are like super, super high above humans as well. But just to think about, you know, the first point, which could potentially be that we reach human level intelligence at some point. And if we just start thinking about that, are you scared about that point?
I mean, it's not like I'm laying awake at night thinking about it, but I think it's definitely a possibility. And I think we need to of course, I don't think it's going to happen in like 5 years. And
50 years, 10 years.
I mean,
years.
50. Yeah, maybe 50 years. And I think that it's probably a good idea to like think about how we should, structure our society if that will happen. And there's probably going to be, we will definitely need to think about how we as humans fit in that type of society. And that's,
As someone said, I'm not sure who, he said, I welcome the AI overlords. I'm sure.
Probably Elon Musk.
No, probably not.
Probably not, actually.
He's very afraid of it, but yeah. Yeah, anyway. Yeah,
I think it was you, Anders.
Maybe. Magnus, do you have any thoughts about that?
No.
You leave it to AI to ponder about that. Erik?
Well, I tend to think of these things in terms of, the evolution of the, from the Big Bang to the first life on Earth to the first mammals to humanity. And we are here, and if you've, if like memetics and stuff like that, like T-memes and so on, I'm interested in the fact that we are developing this while it might be counterproductive towards our own existence. But we are, and we are doing a lot of things that are counterproductive. And we kind of harboring this technological development in general that is sometimes hard to explain, in my opinion. Like it's hard to understand why we are doing it, because we might be, good enough of just sitting on a beach and having a beer. So
perhaps you can at the point where we have AGI, but then you can just do that.
Will it happen? Yes, it will happen, I think. Yeah. But when will it happen? I don't know. I mean, like Kurzweil said, in a few years from now, let's see. I don't know. But it will probably happen in the next 50 years, I think. And when it happens, I think it's going to be a different type of intelligence that humans have. So I'm pretty optimistic. I think that we're going to be able to work with this AGI, or I think we're going to get along fine. I think they have like different agendas and different.
So one thing we have said on this show a number of times about this is that we're not really afraid about AGI when it happens, or human level and AI. What we are afraid about is the narrow intelligence that can happen before we have human level intelligence. Meaning that we have autonomous weapons, we have some kind of agent or bot that goes rogue on the stock market, or something that takes over in biological warfare, or social media, and just completely creates very polarized kind of views and extremist kind of opinions or whatnot. Would you agree with this? It's more dangerous with this kind of narrow intelligence that doesn't have this kind of reasoning or high-level reasoning capabilities that we do have as humans today, and they just go for their own goal. They know I want to kill as many people as possible. Let's just use our drones to go around and kill people.
The way you frame it, definitely. Yeah, but I think you have a really good point. Yeah. I think because that's going to happen a lot sooner.
Yes,
so,
exactly.
So and that's going to be that they could have all kinds of like destructive impact on the world. Yeah. So I think that maybe that even
narrow AI going rogue in the financial market is not so unconceivable, even as a thriller movie today. It's really not,
and it has gone.
It has happened
in a few times, but not.
But it has. But and the only point is that it hasn't gone global impact fully. No. So if you just take that and then you extrapolate times 100, that could be serious. Of course,
okay, but we have to end this podcast on a positive note as well. So, should we take one topic that is a challenge for society, like the climate change or the pandemic or climate change, perhaps? So what do you think the best chance of us being able to handle the climate change that we are seeing today is? Do you think it's Do you think AI will have a substantial impact or importance for being able to handle and be able to solve the problems with climate change today? Or do you think it will needs to have other solutions to make that happen?
Okay. So I think the problem is mostly political. I can end on a kind of funny note.
Yeah.
One of my friends, who is a startup founder in Stockholm, proposed the idea, which I liked, to because one of the big problems is obviously that we're consuming a lot of oil, right? And you have Saudi Arabia that is dependent on selling oil, and you have Russia that is depending on selling gas and so on. So but we can't just stop buying oil, because then they're just going to sell their oil somewhere else. Why don't we just make plastic from the oil and put it in landfills? Because then you're taking the oil from the ground, so you won't get the emissions from the oil ever. Right. And if you can make the plastic, you make plastic products, for example. I mean, you don't need to put in landfills.
That doesn't evaporate into the soil.
That doesn't cause emissions, right? If you can make the plastic in such a way so that it doesn't cause emissions, you can just make it into things that we can use and then put it in landfills, and then perhaps they will get their money. They can drive around in the cars in the desert. And
shouldn't that be Elon Musk's next company, to simply do that? He has fixed the electric cars. Now let's take all the oil and put it in a landfill, and he solved the environmental problems that we have on Earth.
Yeah, I mean, it's the fundamental. All these stranded assets, right, in oil, and that's a political problem. Why, and we don't get around that, and that's why we don't accelerate. So if we can solve the stranded assets problem for these poor billionaires, we could maybe do a little bit better.
Continuously buy this stuff, and then we can build houses out of it and stuff.
I like it.
Awesome. And eventually, it will end up in nothing. That's it.
I like that. That's a crazy good idea.
We have solved on this podcast the future of humanity.
Let's get those awesome. Oil billionaires their money, so we don't get that political blockage. Good.
Awesome. I don't think we can end on a better note. So with that, what's next in your life? What's next in Moduli? Perhaps, Emil, if you would like to start personally or professionally in Moduli, what's going up or coming up shortly?
Well, personally, it's continue to develop as a machine learning engineer. I think it's like super interesting time to be alive in the world of AI, and so much. It's hard to keep track of all the new developments. Yeah. So I mean, excited about that, and that's a personal goal of mine. Then of course, continue to evolve Moduli. Mm-hmm. We talked about a lot, like how will that look in X number of years? And I mean, I think we are pretty, honest that we don't really know, but we know that what we have going on is really good, and we want to, expand on that and build more interesting machine learning products that actually solves concrete problems.
Sounds great. Magnus?
Yeah. I believe, Moduli, we are solving other people's or companies' problems. But we're also investing in startups where we are co-founders and running the machine learning teams, basically. And we're talking about machine learning, it's advanced stuff, putting things in production and so, but just to be both a successful consulting company and be a successful investor and support startups, that's a hard challenge to just do two things and still stay focused. So that's my focus for the next 6 months, to be better on that.
Very nice. Sounds super exciting. Interesting.
Eric?
I would talk about the team, making sure that the team is, really enjoying their work, and the fact that we can expand in a sustainable way, and make sure that everyone learns and that we have great knowledge sharing internally. I think
we should have brought that topic.
The team topic,
but
knowledge
we
sharing.
Didn't have
we
time
had
for
the
that.
knowledge. We got that. Oh,
yeah.
Damn it!
After
work.
Yes. Still have some time after this. Cool. Any anyone that you would recommend to come on this podcast? Someone that you love to hear us interrogate on this podcast?
I think you should talk to Willem von Ehrenheim. He's the principal at EQT.
Oh, EQT.
For Motherbrain, if you know.
Yeah, I know Motherbrain.
We worked with him a lot, and he's a close friend. He's a great guy. You should talk to him.
Yeah,
definitely.
We said we need some VC. EQT, is that VC or is it something else? Am I confusing it? Yeah,
it's VC.
Yeah, but Motherbrain is a company that basically tries to predict what company that's going to skyrocket.
So that's VC and AI.
AI for VC.
That's the combination for this podcast, I think.
Yeah, I mean, it's a great company. Well, any other suggestions from Magnus or Emil? And it should be someone that hopefully can come physically to Stockholm as well.
I can't. I mean, there's probably a ton of them, but I can't bring one to mind.
Yeah.
Any cool customers, Magnus? We should talk to. You're doing some cool stuff with some customers that we should have here. That's a leading question, by the way.
I think usually they don't want to talk so much, but I believe it would be really interesting to hear someone from the governmental sector, because I know there's some people doing amazing stuff out there, and even if I'm saying, why is no one doing something about that, I know there's a lot of people doing a lot of things, so maybe one of those. They're maybe not showing up so often in the tech scene, but I know there's amazing people.
Some specific parts?
I think Skatteverket is not the most sexy organization, but they're doing some cool stuff, and
it's
maybe
one of the most
someone from there.
Yeah. It's one of the most impressive.
We have the same understanding
authorities that we have in Sweden. So yeah,
great. When machine learning AI, they are quite impressive,
for sure. Awesome. Let's do the after work. But thank you very much, Erik, Magnus, and Emil. It's been a true pleasure to have you here. And as usual, we missed so many topics that we could have spoken about, but. Yeah, I love the discussion. So thank you very much for that. And best of luck with future work with Moduli.
Thank you.
Thank you, guys. So much fun.
Thank you.
That's great. Thank you.